How's it going? Welcome, welcome. If you guys don't mind, as you're logging in, answering our little poll, let us know where you're logging in from. We're excited to see. Thanks so much for joining us today. So we're going to hop right in. As you guys have seen in messaging around this webinar, we will have the recording available for everyone after. So, as people continue to roll in, don't worry, we'll have all the information for you. But for those of you that are here, my name is Leah. I am a part of Team tCheck, and I am super excited to introduce our co-founder, CEO, engineer extraordinaire, Peichen Chang. And so if you guys have done webinars with us before, you have probably seen me doing them, and they're a little bit more of beginner friendly. So this webinar is going to get a little bit more technical, where we're going to peel back really kind of the science and engineering behind tCheck to give you guys a little bit closer view into how we work and what we can do. So without further ado, Peichen, take it away.
Hi. First of all, can y'all hear me okay? Leah?
Yep.
Okay, cool. Hi, I'm Peichen. Welcome. Good morning, good afternoon, wherever you guys might be. So we created tCheck, I don't know, quite a few years ago, because just a couple of guys at a dinner table said, hey, can you do fill in the blank? And engineers always say yes, because that's what we do. And so here today, I'm going to talk a little bit about the sort of the science and chemistry and physics and all that behind tCheck, and give you a little bit of an idea how tCheck might compare to HPLC, because we get that question a lot from you folks out there. Okay, so just to set the stage, HPLC is what the labs use, the cannabis testing labs use to measure your cannabinoids. Okay. So let's see. Let me figure out how to share this. I put together a little bit of a presentation first, so that we can I can sort of kick off the discussion here. Share this. Okay. Okay. Oh, actually, I'm gonna go back and forth. Okay, so so under the hood, tCheck is what's called a spectrophotometer. And spectrophotometers work by shining light through a liquid, shining various colors of light through a liquid, and measuring how dark it is, right? And so I'm actually gonna do a real quick demo here. I'm gonna go back to my screen here, if y'all can see. Okay, so here I have cranberry juice. And so you can see the cranberry juice here. Okay, and it's pretty dark, right? And so if I were to shine a red laser through it, you should be able to see that pretty well. Okay, but if I shine a blue laser through it, you really can't see it hardly at all. Okay, and that's because the red color filters out or absorbs the blue color very, very readily. Okay. Now, if I were to say dilute the cranberry juice with water. Now, so for our eyeballs, you can obviously tell that this is a lighter shade of red, right? And again, going back to this, you can still see, the red going through. But now you should be able to see a little bit of the blue coming through as well. Okay. And so this is the property that we use in tCheck to measure how much stuff is in the liquid. In this case, it's the red from the cranberry juice. Okay, but in the world of tCheck, it's the cannabinoids. Now, as it turns out, cannabinoids don't absorb visible light at all, right? We make infusions that are very, very strong, and they look colorless. But cannabinoids absorb UV light extremely well. So that kind of brings us to the next thing here, which is HPLC. Okay. So HPLC stands for high pressure liquid chromatographer. Some people call it high performance chromatographer, but high pressure. Okay, and it consists of sort of three basic parts. right? The first part here on the left is a solvent and the pump. And although there's only one jar there, oftentimes there's two different solvents, water and, oh, sorry, I'm not sharing my screen, am I? Let's see, share presentation. Okay, there you go. Sorry about that. So HPLC consists of three basic parts, right? The bit here, the solvent with a pump, and typically it's two different solvents, right? Water and the stuff called acetonitrile. The second bit is a column, okay? And this is actually what okay, if you guys will see a bit, this is actually what an HPLC column looks like. It's a long stainless steel tube, right? And the column is actually packed with this stuff called C18, right? Which is, anyway, doesn't matter. Okay, and the last bit right here on the right-hand side, the green thing, is the detector, okay? So actually, tCheck is simply just a detector in an HPLC. Now, what an HPLC does is it is able to separate the different cannabinoids. And so what you do is you take your, let's say your infused oil or something like that, and you stick it inside that column. Okay, and then what the HPLC will do is it will start injecting that solvent into the column. Okay, so it'll actually blend the solvent between acetonitrile and water. So so what happens is the certain cannabinoids will hang on to that column more strongly than other cannabinoids. So I like to think of it as like, when we were kids, we used to play with play on the merry-go-round, right? And so, you get all the neighborhood kids, you pile them on the merry-go-round, the little kids, the big kids, all that, and some teenager would then just start spinning that sucker, right? Like this. And of course, the kids eventually start getting flung off the merry-go-round, right? So at first, the younger ones, right, the toddlers, they get flung off first because they can't hold on very strong, right? And then, then the 7, 8-year-olds get flung off. And then finally, the older kids, right? The 12, 13-year-old kids get flung off the merry-go-round. HPLC actually works very, very, very similarly, right? So when we start injecting that, the water acetonitrile blend, the cannabinoids start falling off of the HPLC column, right? Because we put the cannabinoids in the column, load it first, and then we start flowing this solvent through. And so, so the graph on the right is what the HPLC sees. So for example, CBDV always gets released off of the column first because it can't grab onto the column very well, okay? Next comes THCV, CBDA, CBD, et cetera, all the, it's always in the same order, and that's sort of key, always in the same order. And then finally, at the very end, THCA, that guy holds on the strongest, so he gets flung off the last, right? Now, the detector, okay, the detector simply counts the number of things getting flung off of the HPLC column or flung off the merry-go-round. It can't differentiate. The detector cannot differentiate what it is. The column does that. The detector counts how many. So the detector tells you how big the spike is, right, in that graph, and the HPLC tells you where the spike is. Okay, and so that's why HPLC is able to not just count how much how much of one cannabinoid there is in a solution, it can also tell you which cannabinoid there is. Okay, so that's sort of how the HPLC works. And again, the tCheck is actually just the green bit, the detector part of the HPLC. Okay, because the rest of it is actually very, very expensive and difficult to maintain. Okay, now going on to the next slide here. This is an example of the results, the certificate of analysis that we get from our ISO accredited lab. Okay, and so you can see here that this particular sample was 16.8 milligrams per milliliter, mg per mil. But what I want to point out here is that even the HPLC, that fancy machine, has measurement error, right? In this case, it's actually close to 1 mg per mil, right? So 16.8 mg per mil plus or minus 1 mg per mil. So it could be anywhere from 15.8 all the way up to 17.8, and the HPLC can't tell the difference. And so another one of the questions that we get frequently from customers is, how come it doesn't match exactly? Well, first of all, the HPLC doesn't match itself, perfectly every single time, right? It has some level of error. And then since we use HPLCs to calibrate tChecks, we're going to have the HPLC error on top of our own error. So our error band is going to be a little bit, actually quite a bit bigger than HPLC. Okay. So anyway, that's kind of how the lab analysis works and how tChecks are calibrated, right? And then finally, when we designed tCheck, there were several things that needed to happen, right? And one of them was that we needed to make it really easy to use. So we had to simplify a whole bunch of stuff. And one of the most basic simplifications is that we figured, okay, well, you guys know what the heck you're doing. You know what you're testing for, right? You've taken your cannabis plant material, you've decarboxylated it, and so therefore, it should be just THC in there, and so that's what we're going to look for, right? So if you go back to this graph right here on the right, all those little bumps there, when you tell tCheck that, hey, I want to measure THC, just THC, we're only looking for that THC bump. Okay, we're not looking for the THCA bump. So remember, the tCheck is a detector bit. We can tell you how high the peaks are, the bumps are, but we can't tell you which bump it is, right? The column tells you which bump it is. Likewise, if you're testing for CBD or in our hemp testing capability, we can tell you how high that CBD bump is, but we can't tell you it is a CBD bump, right? So to us, it's just a bump, and you have to tell us which bump it is. Okay, so that's one of the sort of the limitations or the design trade-offs that we had to make on tCheck when we built the thing, right? Because we can't make it call, not cost effectively anyway. The next one is testing range. Okay, so tCheck today actually tCheck today actually measures up to 18 mg per mil. This one says 15, but it actually measures up to 18 mg per mil. Okay, but believe it or not, an HPLC only measures up to 1 mg per mil. And what that means is, in order for someone to put a sample into an HPLC machine, you have to dilute the heck out of it, right? 20 to 1, 30 to 1, 50 to 1 dilutions before the HPLC can pick it up, because otherwise the HPLC will say, you know what, it's too dark. I can't see through it, right? In my cranberry juice example, with the full strength cranberry juice, when I put the blue laser through, no blue light made it through. And that's kind of the same thing with HPLC. It's like no light made it through. I couldn't tell you if it's 5 mg per mil or 500 mg per mil. Okay, can't tell, right? Actually, can't do 500, but 50 mg per mil. It can't tell. And so it just says error. And so that way the technician then has to take that sample, go back, redilute it, and then send it back in. And so that's how HPLCs work, and that's how tChecks work. And so that's that's the second design trade-off that we had to make, so that tCheck users don't have to dilute so much. Okay. So that's sort of it for the formal presentation part of this webinar. And I will open it up for any questions that you guys might have at this point. I'll do my best to answer them.
Peichen, our first question is here in the chat. We are getting questions about if the variety of brands of bases like olive oil, MCT, etc., affects the results.
They do to some degree. Okay. So it depends on what you're talking about. Okay. If you're we support alcohol, butter, coconut oil, and Evo, right? Olive oil. Okay, so as it turns out, we do say extra virgin olive oil, okay, because non-extra virgin olive oil actually spectroscopically looks very, very different than Evo, okay. Matter of fact, we can actually tell the difference between real Evo and fake, something that's not really extra virgin, that's been adulterated. Yeah, so there is some difference. Now, if you take a look at a broad brush of different, say, olive oils, most of them will look the same, actually, spectroscopically. Now, if you take two, jars of olive oil from the store, your eyeballs might think that they're different, right? Because one might be greener than the other. But in the UV spectrum, they're actually quite similar. Other things like, say, coconut oil, they're nearly identical to each other. Alcohols, any clear alcohol, say, for example, vodka or white tequila or I don't know, gin, I guess. They tend to look very, very similar to each other as well. Okay, their alcohols are effectively clear. Butter, we have found a little bit of variety in butter, particularly with I think there was a kind of Irish butter I forget the name of it was in the feed for the cows that made the butter. There was something in it that looked different than the others, but most store brand butters like Lucerne and I forget the other Land O'Lakes and stuff like that, they all look the same.
And just so everyone here knows, we're going to be launching another poll question here in a second, actually right now, that is related to the presentation that Peichen just gave. So Peichen, you might want to elaborate just a little bit more on the results of that.
The poll question?
Yes.
Okay, I'm sorry. Would you mind reading to me?
Oh, yeah.
There's a lot going on my screen right now.
Sure. Yeah, actually, while people are reading through the poll question, we did just get another question that I think we should go ahead and answer of trying to calculate high potency. If I put 1 milligram THC oil into 21 milligrams of plain oil, is the calculation multiply the tCheck potency by 42?
Yes, because that's a 42-to-1 dilution.
Perfect.
You nailed it. Whoever asked this question, you nailed it.
Awesome. You're welcome,
Actually,
Jennifer.
I would say maybe not so much milligrams of plain oil, it would be milliliters. So tCheck measures stuff in milligrams of cannabinoids per milliliter of fluids. We did it this way. I guess we can present it in terms of milligrams per gram or percent. But the tCheck was originally designed for edible makers in mind, or cooks and chefs. So typically oils, fats, butters, that kind of thing is measured by volume, right? So either it would be, in the US here, it's teaspoons, tablespoons, cups, that kind of thing. Elsewhere, it would be in milliliters. And I think in the tCheck app and the results screen and some of the others, we have a little converter so that you can convert from, milligrams per milliliter to milligrams per tablespoon or whatever it is, so that you can adjust your recipe easily.
Perfect. And then our question that just came up in our polls is talking about which of the following is not an advantage of UV-vis spectrometry over HPLC. And it looks like you guys got the answer right, which is measure individual cannabinoid compounds separately. So Peichen, can you go into a little more when people are wanting that cannabinoid breakdown, that's part of the kind of trade-off that you were talking about. What does that look like for future of tCheck testing? We just got a question about that.
Okay, so actually the future of tCheck testing really depends on what it is you guys are asking us for. So, when we first invented tCheck years and years and years ago, we did only one thing, and that was measure THC in butter and nothing else. We couldn't measure anything else. And then over time, customers such as yourselves have asked us for additional capabilities, right? So like, measuring extra virgin olive oil, measuring MCT oil, alcohol tinctures, those sorts of things, and measuring raw flour. And so those are all capabilities that we've added to the tCheck device over time. And that was all driven by customers because, enough customers ask for something, we're going to build it. It's sort of simple as that.
Hey, Peichen, there was a question of can they use other bases like corn oil, cotton oil, that sort of thing?
So the answer is sort of yes. Okay. Now, every type of oil has, let's call it a base absorbency. Okay. So for example, if you were to have, I don't know, grapeseed oil. Okay, I use that for cooking for a bit. Okay, so grapeseed oil is pretty close to olive oil in terms of base spectroscopic absorptivity, but it's not exactly the same. Okay, so you can think of it loosely as the base oil has a certain amount of absorption, and then the cannabinoids have more absorption on top of that, so for a total absorption profile. Okay, now it's a little bit more complicated than that because there's some molecular interaction between the fats and the oils themselves and the cannabinoids, so that it's not a simple, hey, I'm just going to subtract off my base. I wish it were that easy. I should probably say there was a huge this was a huge trade-off for us. Okay, if we had limited tCheck to being able to measure 3 mg per mil or lower, we could have done this. But if we made a product that only measures 3 mg per mil, nobody buy it, right? The problem is once you start getting into the denser infusions, above 3 milligrams per milliliter, there's interaction between the fat molecules and the cannabinoid molecules, and so that math doesn't exactly work out. Now, what I'm going to tell you is this: the thing that tCheck is very, very good at, okay, every bit as good as, let's call it, actually, even some HPLCs, okay, is if you stick the same stuff in there, you're going to get the same answer out within a very, very, very tight tolerance. Okay, here in the lab, when we calibrate tChecks, we do that test for every single tCheck in the lab. Okay, and our pass-fail requirement is it has to be within 0.5 mg per mil or better. And in some case, in the case of THCA alcohol, we require 0.3 mg per mil or 0.2 mg per mil or better. So in other words, you stick the same stuff in there, you better get the same result back every single time. So if you're making an infusion with, say, safflower oil, okay, that's something that's not in our pick list of oils that's supported, okay. What you can do is, if you make a batch today and you stick it in your tCheck and you measure, and let's say it gives you a number, right? And let's say it says 12 mg per mil. All right. Now that absolute number might be a little bit off, right? Just because we haven't calibrated your tCheck with safflower. But the next time you make a batch of safflower, and it measures 10 mg per mil, okay, you can be sure that that second batch is 20% weaker than the first batch, right? And so it's a relative thing, right? So you can use that capability to support oils or test oils that may not necessarily be supported. Now, in our little app where it says, are you measuring alcohol or MCT or whatever, just make sure you push the same button again, right? Let's say you measured safflower oil and you use the MCT oil button. The next time you make safflower oil, push the MCT oil button. Okay, so then you get the same answer out.
We also just got another question. Somebody asking, my alcohol tincture is obviously green. Do I need to filter before using tCheck? I'm having problems getting reliable and reproducible results.
Most definitely. Okay, absolutely. Okay, so infusions have a lot of stuff in it. So if you look at your plant, okay, most chemists say a plant is a matrix. Okay, it comprises of a lot of stuff. Okay, and that stuff includes, chlorophyll, and includes plant lipids and waxes. And it includes physical chunks of stuff. Okay, and all of those things can mess up the measurement for tCheck. So, for example, we shine the light through the cranberry juice, and if there's, I don't know, chunks of stuff floating in that cranberry juice, it will impede the light. It'll slow down. It'll stop light from making it through, and we're gonna misinterpret that results. So that's why when we ship tCheck, we do ship it with those 0.22 micron filters, right? 220 nanometer filters, and that gets rid of most of that stuff. Okay. Yeah. So often there's a common misconception out there saying, hey, my infusion's super dark, super green, it must be super strong. Actually, no. It just means you have an awful lot of chlorophyll in it. We also have done a lot of experiments in terms of, okay, well, you know, if I soak my cannabis in the alcohol for, you know, weeks or months, you know, it'll make it stronger. Unfortunately, not really. There's a process out there called WET, which is called quick wash ethanol something. Quick wash ethanol. Okay, where you take the cannabis plant, you soak it in ethanol, which is, you know, effectively, I don't know, very strong vodka, I guess you can say, for about 15 minutes, and then you filter off the plant bits. Okay, and that's because the cannabinoids dissolve in alcohol extremely well. It goes off very, very fast. And then after that first, you know, initial, you know, 15-minute extraction, you're effectively just extracting other stuff at this point. You know, the lipids, the waxes, you know, chlorophyll, all that kind of thing. So to answer the long answer to your question, absolutely, you have to filter.
In our poll that we just posted of what's your biggest challenge with at-home potency testing, the vast majority of the responses are understanding dilution calculations. Can you elaborate a little bit more on the need for dilution calculations with super high readings or super strong samples?
Yeah, that okay. Maybe this is one of those things that you guys can help us out by I don't know. How would you do that? We have been working on potentially a I guess a user interface modification or something to help you guys walk through the dilution calculations. Okay. And you know, you saw my cranberry juice example, right? You know, I started with 100% cranberry juice, light through it, no blue light. I diluted 4-to-1, and we saw some blue light, right? Okay. Some of the difficulty is that it's a little bit once you get to the thick end of the scale, it's a little bit difficult for us to figure out or make a recommendation on how much to dilute it. Okay. So let's see, how can I say this? So for example, we've made 100 mg per mil samples here in the lab. It's really hard to do, but it can be done. Okay. Now in order to test it inside a tCheck, it's a 10-to-1 dilution. Okay. On the flip side, if you make a 20 mg per mil solution, you know, tCheck will say over. Sorry, I can't read it too thick. And if we suggest a 10-to-1 dilution, you're going to be down in the sort of in the dirt zone, in the floor. So again, you know, so it measures best sort of in the middle. And so one of the challenges that we have is figuring out if we can make a recommendation on dilution for you to measure better. Now, having said that, you know, for you to dilute, first of all, let's say you make a jar of you know, THC, MCT oil. Okay, really rich stuff. Okay, there was a few people thought that you had to dilute the whole thing. No, just take a little bit. You know, take a teaspoon of your oil, your MCT oil, and then take another teaspoon of, you know, uninfused MCT oil. Put them together, mix it up, test it, and that's a 2-to-1 dilution, right? So just measure it, take your answer, double it, measure, and that's how strong your oil is. If that doesn't work, try 3-to-1, 4-to-1. I wish I had a better answer for you, but I really don't. I'm sorry.
Another question of, is there tips and tricks for best practices with using filters, syringes properly with tCheck? And I would also add to that question with proper tray use as well.
Oh, okay. Let's see. Shoot. I'm always every time I do something, I wish I had that other thing here for show and tell. Okay. So first of all, make sure the syringe is clean. Okay. Because if you have residue from the previous test or something like that, you're gonna throw out your measurements. Okay, so what we do is we take the syringe, dip just the tip part in the solution. So, sorry. So just this top bit in the solution. Okay, you don't want to stick the whole thing in there. Okay. Besides, it'll get your hands all oily. So take and then withdraw some fluid. Okay, and then put the filter on. Okay, and then I always just hold the filter bit and then start squeezing the oil through. Just because there's a few times where I didn't do that and the filter popped off. You also don't want to squeeze too hard, okay? Because if you squeeze too hard, you'll blow a hole in the filter and then you're kind of lost again. And so just squeeze just enough where the oil starts dripping through. And I think for folks who have used the tChecks before, 2-3 drops is all you need. The filters are not reusable. They're not cleanable, unfortunately, just because the pore size is so small, right? 0.22 microns. And so, then you basically have to toss it. Yeah. So that's, to me, that's best practices, for using the, syringe and the filter. Okay. With regards to the tray, always please hand wash the tray. Simple Dawn dish soap will do. I want to show you something real quick here. This is a tray where it's even hard for me to figure out. This is a tray where somebody stuck it in a dishwasher. You can see it's pretty well worked. Yeah. Unfortunately, this is no longer salvageable. So we had to take the tCheck back and recalibrate it with the yeah, so please hand wash the tray.
Another question of the tray. Can you walk us through kind of the anatomy of the tray for someone testing?
Yeah, sure. Okay, so I'm gonna find me a good tray. Okay, so tCheck trays. They might look pretty simple, but they're actually pretty interesting beasts. Okay, we spent quite a lot of time engineering this thing. Okay, so the bottom half of the tray, top half of the tray. Okay, by the way, the easiest way to open and close the thing is trays like this. I grab it from the side. Oops, sorry. You can see the tray bottom has these little lips right here. Okay. The side, I hold it like this. The top I hold like this, right? If you hold it like like this, and it comes apart really easily. Okay, so anyhow, tray bottom. Okay, take your oil, you filter it, put 2 or 3 drops in here. Okay, and the interesting thing about this tray, okay, is that it has a convex surface like this, or concave surface like this, and a convex surface like this, right? And when they come together, there's a tiny little gap between the two. Okay. That gap is 0.2 millimeters. It's very, very, very small. Okay. The tray is designed so that this area right here, any excess fluids get squeezed into this outside capture zone, so that you don't get the oil into your tCheck device. And so what this results in is that every single time when you put oil in the tray or into the tray and they squeeze it together, you get the same thickness of oil. And that is super, super, super important for spectroscopy, right? Because now it's very, very consistent. Every time you stick that fluid in, we're shining light through exactly 0.2 millimeters of what we call path length, right? 0.2 millimeters of the fluid. Standard spectrometer cuvette. Let's see. A standard spectrometer cuvette looks something like this. Okay. And this one happens to be made out of quartz. Okay. This one has what's called a path length, or the light goes through it from this side to this side, for 10 millimeters. So it's very, very, it's a lot of distance for the light to travel through for measurement. And these things are basically no good for for cannabinoid measurements. If you do want to use this for cannabinoid measurements, you have to dilute your cannabinoid something like 200 to 1 or more before you can even get a signal out. Okay.
There was another question related to dilution. So someone's asking, how should my workflow be? Test first if less than or greater than 15 milligrams per milliliter, dilute 1 to 2 ratio, and test again.
Yes.
Okay.
Yes. Sometimes here in the lab we use a factor of 2 dilutions. So what I do is I do a 2 to 1 dilution, and that's too dark. If it's still too dark, I'll do a 4 to 1 dilution. If that's still too dark, I'll do an 8 to 1 dilution, right? So it's almost like, ranging, right? So I take out my golf club, right? I hit a 9 iron. I'm too short. Okay, well, I'm gonna go to a 7 iron. Still too short. And I go to a 4 iron. Well, I can't hit a 4 iron to save my life, but still, that's sort of the way you do it to figure out, okay, well, about how far am I? Right. And if you need more accuracy for that one, once you get to that, sort of the bracket, too light, too dark kind of thing, then you kind of go in the middle.
Okay, and then next we've got a question about rosin. So, testing rosin with tCheck, is it possible? Is it not? Why? Why or why not?
Okay. So unfortunately, the answer is no. All right. Because so rosin is a process where you take the plant material, you stick it in a hair iron, a flat hair iron, and use heat and pressure to squeeze all the good stuff out of the plant. Okay, it works amazingly well. Okay, unfortunately, it works amazingly well at squeezing all the other stuff out of the plant material as well. Right, as I mentioned a little bit earlier, the plant is a matrix. It's got a lot of stuff in it besides just cannabinoids, and that the rosin press technique actually squeezes everything out. All you're left with is really cellulose. If you go to the dispensary and you're to buy some plant and there's a label on it that says, hey, I'm 27% cannabinoids, right? 27% delta 9 or delta THCA. Well, that also means that it's 73% other stuff. Okay, and trying to figure out what that other stuff is quite challenging, and that's where the HPLC really is going to shine, right? Because HPLC is able to separate what all the other stuff is, right? It'll say, okay, well, this bit is plant wax, right? Not cannabinoids. I don't need to worry about that, right? That sort of thing.
Another good question that I haven't seen before, does the inside of tCheck need any cleaning at all?
No. Okay, so I remember when I said that the tray has a very predetermined thickness to it. Okay. Okay. For those of you that are curious, it's kind of dirty, but this is what the inside. This is what the sort of the inside of the tCheck looks like. Okay, so we have two printed circuit boards. Okay, what we call motherboard, daughter board, and then this plastic frame that kind of holds everything together. Okay. Okay, so this is sort of a plastic frame. Okay, and then if you start taking it apart, this is what the motherboard and the daughter board look like. Okay. Okay, so these are the color LEDs that you guys see through the logo. These two are the UV LEDs. UV LEDs that we use. Okay, because we use a couple of different wavelengths or colors of UV, and then this white thing is the is a photo detector. Okay, now what happens is when you put all this stuff together, okay, we have other things in the tCheck that exert what I call Z-axis pressure. Okay, so inside the case, we have features in the plastic that basically take when the tray goes into the thing, it holds it, so that it doesn't tilt, yaw, all that kind of stuff, and it holds it in a certain position. Okay, we also have other features that squeeze it together with a certain amount of pressure. Okay, it's not a, it's part of the outer case, but that squeezes it together a certain amount of pressure. When we calibrate tCheck, okay, the reason we calibrate each one individually is because due to manufacturing differences of the tray itself, the plastics, and all that kind of thing, there's gonna be tiny variations in pressure. Okay, and the calibration process calibrates out all those minute differences. Okay, and so if you take apart your tCheck to try to clean it, what happens is you're going to mess up all of that z-axis pressure z-axis pressure capabilities that we've calibrated into tCheck, and you kind of mess it all up. And so unfortunately, no. Now, okay, if you look into the tCheck slot, okay, right into the slot here. Okay, sorry, this one's really dirty. Okay, now you can see that there's holes in it to prevent liquids from spilling onto the electronic bits. Okay, now if a little bit of stuff happens to fall and get squeezed out of the tray and into the slot, okay, into the slot itself, you can actually clean it with a Q-tip, right? Just a little bit of alcohol and Q-tip, it'll wipe out of it. But if you happen to get oil through those little holes and onto electronics, unfortunately, we do have to recalibrate the thing.
Okay, our next question is, I would like to test the CBD and THC content from my flower to find the ratio between CBD and THC. What would be the best way to do that with tCheck?
Yeah, unfortunately, that's a capability outside of tCheck. In order to do that, you really do need that column in the HPLC to separate the two cannabinoids to be able to do that. So I'm really sorry, but the chemistry and the physics, we just can't do it.
Another really good question is the tCheck sensitive enough to detect degradation in stored infusions over time? How might someone use it for quality control?
Yeah, sure. That answer is actually yes. So when we make our calibration standards here in the office, okay, I'm gonna go ahead and give away a little bit of trade secret today. Cannabinoids oxidize, okay, and it's most noticeable if you take pure cannabinoids, like say CBD that you can buy on Amazon, pure THC if you're able to source that stuff. Okay, you stick it in, it's really apparent in say something like MCT or alcohol because they're white and they're clear, they're colorless. And over time, you're going to see the THC start turning purple. Okay, or the liquids start turning purple, and that's due to oxidation of the cannabinoids themselves. Okay, now over time, tCheck, okay, we'll be able to detect that the cannabinoid content will decrease. Okay, it's very slow. Okay, but it definitely happens. So what I recommend is if you do make infusions and you plan to store them for a long time, okay, is to get, shucks, I don't have it, sorry. Is to get that wine keeper stuff, like that argon gas stuff, that gas stuff that you use to squirt and spray into your bottle of wine to keep it longer. Get that stuff, okay? Squirt it into your jar of infusion, seal it up tight, and stick it in. Actually, we'll stick it in the freezer. Because so two things will slow it down, right? The fact that there's no oxygen in the jar, okay, that will slow down oxidation, and cold will also slow down oxidation. So if you do need to store your infusion for a long time, that's sort of the way to do it. That's how we do it here in the lab, so that our calibration standards stay consistent over time. Again, we send a lot of samples to the lab. In fact, it's actually weekly that we send these samples to the lab to ensure that the standards stay the same, and that and the standards don't move, right, due to storage conditions. So minimize the amount of air, minimize light, and minimize temperature. So make it cool.
Awesome. And just so everyone knows real quick, we have time for about maybe 2 or 3 more questions, but I wanted to let everyone know that if your question doesn't get answered today, or maybe if there is a question that comes up after the webinar, we've set up an inbox for you guys specifically for people who are here attending the webinars. So I'll put it here in the chat, but if your question doesn't get answered today and you would like to get that question answered without having to go through a customer support ticket, you will just email webinars@tcheck.me. And again, I'll put that in the chat. So any questions that you guys have left, please drop them in the chat and we'll answer our last couple of questions here. One that came up, Peichen, which I know you probably have a great answer for this, but could you share a real life example where tCheck helped a user discover a dosing mistake or adjust their infusion recipe successfully?
My favorite was a guy that came back from Afghanistan. And you know the kind of stuff that they went through. And so he was using cannabinoids to manage his anxiety. Okay. And so the problem was that he had a day job, right? And day job didn't do much. There was no requirement for drug testing or anything like that for his day job, but he still needed to be functional. Okay, and so he would microdose, right? He would take. I don't know if you all have heard of bullet coffee, right? You add a little bit of butter, you add a little bit of MCT in your coffee, and it helps a lot of folks. Okay. Also tastes pretty good too. But what he would do is he would add a tablespoon of MCT oil to his coffee, a tablespoon of infused MCT oil to his coffee. Okay. And the issue here was that some days the MCT oil was too strong, right? And so, it affected his work. And other days the MCT oil was too weak. And so, his symptoms didn't get treated. And so, we sent him tCheck, and he was able to now to use it to consistently dose himself, right? And so, every morning he would take 2 milligrams of cannabinoids, just 2. It's a tiny dose. Most people can't even feel it. And it would make him feel so much better. And so, to me, that's a story that I love, right? Because we help somebody. He gave a lot, and now we can help get his life back on track again.
Love that story. We have another question that just came up. So if I decarb my flour and tCheck said it was 23%, can I assume that my rosin pressed from that flour will be less than 23%?
It'll be 23% actually. How about this? It will be no more than 23%, but it'll be pretty darn close to 23%. Well, okay, so in all fairness to this, okay, I gotta say this. When you rosin press it, okay, all the cellulose is gonna come out of it. So technically the amount of weight is gonna be reduced, right? So your percent is milligrams of cannabinoids divided by total weight of whatever material it is. So if you do that, I guess fortunate and unfortunate, it doesn't matter, but the denominator of that equation will decrease, right? Because the weight will be smaller, right? Yeah. So maybe I didn't answer it originally correctly. So yes, the plant material is 23%. The rosin, less sure about just because the denominator is not sure. You know what? I don't know who asked that question, but you got me thinking about something. I might try to. I'm gonna go back and do some more homework to try to figure out if there's a way we can help you out here. Because we might be able to do something like measure the weight of your flour before pressing and measure the weight of flour after pressing, and then do the math that way. So I don't know who asked the question, Leah. If you don't mind, please take a note. And you might have just helped us invent something here.
This is what we love about our tCheck community too, is you guys are always getting our gears turning with new directions to go in, which is going to bring us to our final question of today. And before I ask our final question, I wanted to make sure everyone here knows that we're giving all webinar participants 15% off. And you will use code TechWeb at checkout, and that will get you 15% off of your tCheck bundle. So that will be live for the next 3 days, exclusive to people who have attended the webinar. So we will definitely keep you updated on that answer. Robert, thank you for asking that question. You guys will all get a follow-up email after this that includes the recording. And so, we'll have your contact information, and we will definitely reach out when we have an update on that. So great questions, everyone. We really appreciate it. So Peichen, I know you kind of touched on this a little bit, but for our final question, it is what's next for tCheck in terms of, are there plans to expand into testing other cannabinoids or raw plant material?
Let's see. My engineer's gonna hate me for saying this. We've actually had a lot of requests for testing psilocybin. That's come through a lot. The hard part about psilocybin is actually getting the calibration material. We've actually very, very successfully tested psilocybin and psilocin. But from a manufacturing and operations perspective, we've not been able to successfully consistently source calibration material. Okay, so if any of y'all out there has a lead on that kind of thing, hook us up. Now from a cannabinoid perspective, okay, I'm actually going to let you guys drive that. Okay, so you said Robert was the one that had the idea or the concept on rosin testing. So after this, I'm gonna go do some homework and try to figure out if I can get it done. Okay, yeah, I'm gonna go steal my wife's hair iron and do a whole bunch of testing. Okay, so I can't promise that we can do it, but I can promise you I'm gonna go try.
A true engineer at heart, right? All right, guys. Well, that is about it for us today. So it seems like people got really excited, Peichen, with that psilocybin answer. So you guys stay tuned. We with this community, we love hearing from you guys. We love hearing feedback because we're doing it to make testing more accessible and easy for you guys. So like I said, if there are any additional questions or as we're saying, any ideas come up, please feel free to email directly to webinars@tcheck.me. And we will be planning on doing more of these in the future. Thank you guys for your feedback on that. I'm glad you guys are enjoying them. And don't forget that for the next 72 hours, you can get 15% off your tCheck bundle using TechWeb at checkout. All right, so you guys will get an email with our recording. Peichen, any final words?
No, I really appreciate all of you guys joining on. I love the questions. The engineer in me, just we'll dive into this stuff all day long, right? And so thank you. Yeah, let's stay in touch. Thanks. Have a good day.
Thanks, guys. Have a great weekend, and we'll see y'all soon. Bye, guys.